electromagnetic waves or plane wave propagation. Plane wave propagation. The propagation of the wave is in either in any medium, that is either in a space, either free space, or in a dielectric medium. We will discuss the plane wave propagation in different medias. Generally, if you consider the solution of any electromagnetic problem, if you consider the solution of any electromagnetic problem, the fundamental relations that must be satisfied are nothing but Maxwell's equations. So, if you consider any electromagnetic problem, the Maxwell's equations must and should hold good. We already discussed Maxwell's equations. So, just for a review purpose, we will write down again the Maxwell's equations here. What are the Maxwell's equations? Del cross H is equal to J plus dou D by dou T. Del cross E is equal to minus dou B by dou T. Del dot D is equal to rho or rho V also. In some textbooks the notation is like rho, some textbooks the notation is rho V. Del dot D is equal to rho V. Del dot B is equal to 0. So these are the fundamental Maxwell's equations we know very well. Another relations are D is equal to epsilon E. B is equal to mu H. J is equal to sigma E. We know these relations also. Generally or particularly for a particular case of electromagnetic phenomena, we will consider in free space. So, free space. So, we are considering the electromagnetic phenomena in free space. So, what are the characteristics of free space? Free space means there is no free charges. Free space means no free charges. So, no free charges means this implies rho V is equal to 0. Rho V is equal to 0. What is the conductivity of free space? Conductivity of free space is almost all equal to 0, approximately equal to 0. These are the properties of free space. So then what about Maxwell's equations in free space? Del cross H is equal to, what happens? What is J? J is equal to sigma E. But for free space, conductivity is 0. So, J is equal to 0. Current density is equal to 0. Therefore, del cross H is equal to only dou D by dou T. Del cross H is equal to dou D by dou T. Consider this as equation number 1. Similarly, del cross E is equal to, so directly it is minus dou B by dou T. Del dot D is equal to rho V, but rho V is equal to 0 for free space. Therefore, del dot D is equal to 0. and del dot B is equal to 0. Consider this as equation number 2, this as equation number 3, this as equation number 4. So these four are Maxwell's equations for a particular case, or we are considering here the electromagnetic wave phenomena in free space. So the properties of free space are, there is no free charge existing in free space. That implies rho v or rho is equal to 0. Conductivity of free space is almost all 0, approximately equal to 0. So modify the basic Maxwell's equations. So we got 4 equations. Now I am taking the equation del cross E, that is equation number 2 I am taking. So the equation del cross E is equal to minus dou B by dou T. I know B is equal to mu H. B is equal to mu H. Therefore, del cross E is equal to minus dou by dou T mu H. Mu H. This is nothing but del cross E is equal to minus mu into dou by dou T of H. Dou by dou T of H. Now we can modify this equation further. What I am doing is here is take curl on both sides. Take curl on both sides. So curl means the operator delta cross. That is, if I take curl on both sides, del cross E is equal to minus mu del cross H dot. Since I am writing this dou by dou T of H as H dot. Dou by dou T of H as H dot. So minus mu into del cross H star. Now how we can modify this equation further is, I know from equation number 1, what is equation number 1? Del cross H is equal to dou B by dou T. Del cross H dot. Del cross H dot. Nothing but what? Take another differentiation. Nothing but this is d square by dt square d. D square by, that is dou square by dou T square of d. This how I can write is, because the d is equal to, I know d is equal to epsilon E. Therefore, del cross H dot is equal to epsilon dou square E by dou T square. So this I am writing epsilon E double bar. Since E double bar is nothing but dou square by dou T square of E. Second order differentiation. So like this I am modifying equation number 1. Now what I am doing here is, this del cross H bar I am substituting in the above equation. Then what happens? Del cross E is equal to minus mu into del cross H star I am replacing with epsilon E double bar. Epsilon E double bar, double dot. That is the second order differentiation, dou square E by dou T square. Now, by using the vector identity del cross E, how I can write del cross A? By using a vector identity, del into del dot E minus del square E. This is a vector identity. You know it very well. Del cross A is equal to del into del dot A minus del square A, where A is a vector. Similarly, use the same vector identity here. Then I can write del cross E as del into del dot E minus del square E. But here I am considering free space phenomena. Free space phenomena. What is the equation number 3? Equation number 3 is del dot D is equal to 0, implies a del dot epsilon E is equal to 0, that implies a del dot E is equal to 0. This is equation number 3. Equation number 3. That is, I know del dot E is equal to 0 for free space. Substitute in the vector identity, then what happens? I can write del cross E as this del dot E is equal to 0. So this is nothing but minus del square E. Del cross E is equal to minus del square E for free space. Now substitute this vector identity in the main equation. Then what happens? If you substitute del cross E as minus del square E, therefore minus del square E is equal to minus mu epsilon E double dot. Minus is cancelled out. Therefore del square E is equal to mu epsilon E double bar. So this is the equation I simplified by using based on Maxwell's equations and for a particular case of free space. So del square E is equal to mu epsilon E double bar. So for any electromagnetic problem, this is the law that the electric field must obey. That is, the electric field must satisfy this equation for any electromagnetic problem. So this is nothing but what? Del square E, I can write this also del square E is equal to mu epsilon dou square E by dou T square, because E double bar is nothing but second order differentiation, dou square E by dou T square. Similarly, in a similar manner, here what I did is, for derivation of this equation, I consider the second equation and I take curl on both sides and I substitute the necessary requirements. Similarly, you take first equation, that is del cross H is equal to dou D by dou T. Take curl on both sides and substitute and convert the entire equation in terms of H. Then you will get a equation del square H is equal to mu epsilon H double bar. Del square H is equal to mu epsilon H double bar. This implies del square H is equal to mu epsilon dou square E by dou T square. Dou square E by dou T square. So you consider this as some capital equation number 1, this is capital equation number 2. This 1 and 2 are called combinedly wave equations. This 1 and 2 are called wave equations. That is, for any electromagnetic wave, for any electromagnetic phenomena, these are the two equations the electric field and the magnetic field must satisfy. These are also called as wave equations for a particular case where the media is free space. Media is free space. So the capital equation number 2 is the equation that magnetic field H must obey. Magnetic field H must obey. Suppose if you observe these two equations, del square E is equal to mu epsilon E double bar, del square H is equal to mu epsilon H double bar. If you observe these two equations, these two resemble same. So you don't think that these two equations are resemble same. E is equal to H. E is equal to H. But even though the two equations resemble same, E never equal to H. E never equal to H. So E is not always equal. E is not equal to H. E is not equal to H. These two are two separate independent equations. Independent equations. So you have to keep in mind these two equations. These two equations must be on your finger tip. Next concept is uniform plane wave propagation. Uniform plane wave propagation. So we derived two wave equations. Del square is equal to mu epsilon del square dou square E by dou t square. Del square H is equal to mu epsilon dou square H by dou t square. We derived two wave equations. What is this uniform plane wave propagation is? The two wave equations what we derived reduces to a simple form. Reduces to a simple form in a special case. In a special case where the electric field and the magnetic field are considered to be independent of two dimensions. So here this is a very special case because in free space, that is three-dimensional x, y, z. Both electric field and magnetic field exist on all three directions. That is, the wave is propagating in all three directions. But here we are considering a special case where the electric field and magnetic field are independent of two directions. Here the electric field and the E and H are independent of two dimensions, means there is no wave propagation in two dimensions. Remember, here there is no wave propagation in two dimensions. Then we can call it as a uniform plane wave. Then if the wave is independent of two dimensions, means the wave is stick to only one plane. That is, it is propagating in only along one axis, only along one direction, one axis. That is, it is independent of a particular plane. So that's why it's called uniform plane wave propagation. Special case where the wave is independent of two dimensions. Suppose, for example, here I am considering the wave is independent of y and z directions. The wave is independent of y and z directions. That is, there is no propagation in y and z directions. Then what happens? What are the wave equations? What are the wave equations? Del square E is equal to mu epsilon dou square E by dou t square. This is the wave equation. But what is del square? Del square E. Del square E means dou square E by dou x square plus dou square E by dou y square plus dou square E by dou z square. Here I am assuming the wave is independent of two directions. The wave is independent of two directions. That is either y and z directions. So there is no propagation in these two directions. That is these two terms, the variation along this y and z as considered as to be zeros. Then I can write del square E as only dou square E by dou x square. Then what happens to the wave equation? Therefore, dou square E by dou x square is equal to mu epsilon dou square E by dou t square. So this is the wave equation for a particular case where the wave is the propagation of the wave is independent of two directions, y and z. So then the wave equation reduces to this simple form. Similarly, dou square h by dou x square is equal to mu epsilon dou square h by dou t square. This is for magnetic field. That is, if you consider this equation only x, that is the propagation or the variation of the wave is only along x-axis, dou square by dou x square. So in the examination there is a possibility of asking a question like this. They will give you a wave equation like this, similar to this, dou square E by dou x square is equal to mu epsilon dou square E by dou t square. The wave is propagating in which direction? Either x, y, z or something. Options is like this. We can clearly say here the wave is dependent upon only x. So definitely the wave is propagating along x direction. The wave is propagating along x direction only. The wave is propagating along x direction only. You can say easily based on this.